This is going to be the last video for today's lesson. So you have done evaluating expressions. Now we can go into the introduction of functions and kind of bring everything together, but we're still going to be doing some plugging ins. Okay, so what is a function? Maybe your 7th or 8th grade teachers, middle school teachers may have introduced this, but if not, I'm just going to introduce it right now. Really for you guys right now, a function, here is one definition. A function is an equation. If you guys have seen equations before, y equals mx plus b, so this is a function, so an equation, so an example, okay? So you've seen something like that before. I'm going to give you guys maybe a little more detailed explanation. Like, what is an equation then? Like, what is a function? What is an equation? It is a relationship and that relationship really could be an equation such that for every x input, oops, sorry, let me just read this. There is a y output. Okay. So it's a relationship, aka an equation, such that for every x input, there is a y output. What a lot of students like looking at is that they think of a function pretty much as a machine. And so maybe I can draw some sort of box machine over here. So here we go. Here's like your function machine here. And then maybe these could be your x values, and then these can be like your y values. Okay? And you've already been doing this, and you've already done it. At least you've done this in the first part. You plug in a certain value. Let's say, for example, you plug in 3, and then you put it inside the function machine, and then out comes -5. Okay? Or you plug in maybe 0.7 inside this function machine or equation. Okay? So you really plug it in the equation, and then out comes 52.3. Whatever this function machine or this equation represents. Okay? So this is what I mean, that for every x input, so you put it in the machine, you put in the function, there is a y output. Something comes out. Okay? And actually, this is a good basis for some of you guys might want to getting into like programming or computer science. This is where it's being used, this type of logic. I know a lot of you guys are in social media, so example, or thinking or know people that have social media. Okay, so for example, on Instagram, when you double tap something, okay, if you double tap a picture, what happens on IG? What happens is they will receive a heart or a like or whatever this is called. Okay, so this is really the basis of computer programming and computer science. You do something, something comes out. Okay, so it really it can relate back, and it really does relate back to the everyday world that we are doing. What does function notation look like in algebra? So this is your most basic function notation, f of x. So you say f of x, okay? This is a name. This is the name of a function. Okay? It's pretty much kind of like saying y, okay? Same as y, like y equals. Okay? This is not multiplication. This is not f times x. No, no. Okay, so this is f of x. there are different representations, and you guys will see it starting on number 13. You guys can see it like this. F of x is equal to 3x plus 5. Okay, notice how what I've written down and what I'm writing right now, y equals 3x plus 5, this is the same. Okay, it's just that now we're giving it like, I guess, a formal name, f of x. Okay. Inside over here, this x, what's a little bit the difference between the one that I've written in green, which you guys are used to, and notation function over here is these are, the input variables are matching. Okay, input variables. So they're telling you what variable we're using. Oh, we are using x for our variable, and that's what we're going to input. Okay, and then your answers today are going to look like something like this. G of 9 is equal to 10. Okay, so this is our input, our x value. We inputted x. And then this is our, I guess, y value or g of x value, our output. So something goes in, and then we get something out of that. Okay, so those are the notes for this. Let's get down to the examples of the work, which I have 3 more. And then that is it for me today. And I'll show you guys again the expectations of what I'm wanting from you guys by the end of this video. So we are evaluating. Let's take a look at 13. F of x is equal to 2x minus 1. Find f of negative 8. So what we're really doing is all the x's that we see, we're just going to plug in negative 8. So again, we are just only doing plugging in, substituting. Okay? So f of negative 8, we're just telling this machine, this function, plug in negative 8. That's it, which you've been doing already. So we're going to go easy kind of today, okay? Once you have this, again, this is f of negative 8. This is just a name, so do not multiply this part over here. Then you're just going to finish off the right side using PEMDAS. Okay, so do PEMDAS over here. Oops, sorry. So you would do the multiplication first, which is going to be negative 16, and then after that, minus 1 is going to be negative 17. Let me just check to make sure that that is okay. Negative 17, good. Okay, so I want you guys to write your answers like this, doing 2 ways. So this is going to be function way, function notation. You plug in negative 8. F of negative 8 equals negative 17. Okay, so to say it again, f of negative 8 is equal to negative 17. Again, what this means is we plugged in negative 8, out comes negative 17. So we put in or input, and then this is our output, what the machine gave us out, negative 17. So I want you guys to write your answers in 2 ways. So this is the first way I want you guys to write your answer. The second way is coordinate form. So you need to present 2 different ways of writing this answer. Function notation and then coordinate form. Really, when we're talking about coordinate forms, I hope that you guys can see that this is also an input and output. If we were to graph this, you would go 8 to the left, and then 17 down on the XY graph. Okay, so please write it in 2 different answers, 2 different forms. Function notation, f of negative 8 equals negative 17, and then coordinate form, negative 8, negative 17. Okay, and just to make sure when you guys start at number 16, from number 16 on, if you take a look at the answer key, it kind of also reminds you like, hey, you got to do function notation and also coordinate form. I'm going to do 2 more, and then that is it for the video. So let's do number 14 now. Okay. We have our function, f of x is equal to negative 3x squared plus 2 minus x. What are we going to plug in for x? We're going to plug in negative 6. So be careful. Sometimes there's more than one place, and sometimes 3 places where we got to plug in that negative 6. Okay. So let's start. F of negative 6 equals negative 3 times parentheses negative 6 squared. And the reason I put parentheses over here is because we want this to do first, the negative 6 squared, plus 2, that doesn't change, minus negative 6. Hopefully you guys can see that, okay? So minus, and then what is x? Negative 6. So minus negative 6. Again, this is a name over here, f of negative 6, so you're not going to touch that. What's going to happen is you're going to do PEMDAS on the right side. So PEMDAS on the right side. So do the right side. Okay, we have to do this first. Okay, a lot of students think that we got to do negative 3 times negative 6. Do not do that. You have to do exponents first. Okay, exponents first. And not negative 3 times negative 6. Okay, so let me just go down to get a little bit more room. So please do exponents first. Negative 6 times negative 6 is positive 36. So it will be like that. Plus, and then I'm going to change this. A minus negative turns into what, you guys? It turns into positive. Okay. All right. I had to use the calculator a little bit. Now we can do the multiplication. Negative 108 plus 2 plus 6. We are only left with additions, so we're going to go from left to right. So negative 108 plus 2 is going to be negative 106. And then negative 106 plus 6 is going to be negative 100. Okay? All right, we're going to write this in two different ways. F of negative 6 is equal to negative 100. Okay, this is the name, and then this is our output. So input, we inputted negative 6. Output is negative 100. Okay, so here is the first way to write the answer. The second way to write the answer, I need you guys to write it in coordinate form. Negative 6 comma negative 100. The reason why we're writing it two different ways is because later on we are going to be graphing these functions as well. Okay, so you need to be good or looking at two different ways of expressing this answer. F of negative 6 equals negative 100. Negative 6 comma negative 100. Just want to make sure it is negative 100. Yeah, okay. Okay. So we've done linear functions, 2x minus 1. We've done some parabolas, and how you can tell this is a parabola is because we have an x squared over here. Now let's go do an exponential equation. And how you can tell it's an exponential equation, remember this is from last class. We have the variable at the exponent. And we are going to plug in what value? 1. So we're going to plug in 1 for n this time. H of 1 is equal to 3 to the 1 plus 2. And don't forget this plus 1 over here. Some students kind of tend to forget that there's some numbers at the end. Okay, well, let's just do the exponent. This is to the third power. 3 to the third power is 27. That's 3 times 3 times 3. And 27 plus 1 is going to equal to 28. I just want to make sure that's, yeah, that's good. Okay, all right, two different ways again to write this, and you need to be writing it down. H of 1 is equal to 28. So that's 1. And then, so we have expressed the answer in function notation. Please also express this answer in coordinate form. And how to do that? It will be 1 comma 28. All right. This is pretty much it for today. Again, the expectation, this is the expectation over here to show your work. Expectation. Really, when it comes down to it, like the way I teach it, I just want to see you guys doing the step-by-step because I'm not there with you. And sometimes, like, you know, for some people, they can do it in their head, but because I haven't had one-on-one time with you guys yet, I need to see that your thinking process, I need to see that thinking process, and one way to show this thinking process is this. So expectation of showing work. Let me just look at number 17's answer, negative 37. If you just put negative 37 like this, I'm going to tell you this is not an expectation. I'm going to return this on Google Classroom. And I'm going to ask you, okay, please show more steps like this. How do you show steps again? Look back at the video over here and these notes. That is it for today. Please now do the rest of the problems. Do numbers 16 and really all the way to the last problem, which is 27. And make sure you are writing the answers in these two formats and also showing your work. Thanks, you guys.